All right, let's keep on keeping on here. Now, this section throws this huge topic in the middle of this section. All right, well, honestly, at the end of this section is really what's going on. Inverse trig functions. This could deserve, in my opinion, a whole section all to its own because it's that big enough concept. And we'll get into it more later, honestly, so we're just talking about it now, but we'll get into it more in chapter 10. All right? But for now, we're just going to set the stage, if you will, with our inverse trig functions. Now, remember when we talked about inverse functions? An inverse function means that I'm going to swap that input and output. The same thing is applying here. The exact same thing. If I have the sine of theta equals y or whatever value, right? So the sine of theta, if I have this inverse trig, we are swapping those inputs and outputs. Just like when we had that inverse functions and we put that -1 up in the exponent, the same thing that's happening here. My symbol for inverse trig means that I'm going to have the inverse sine of y, which is the output, equals my angle. So here's the big deal when it comes to this. When you have inverse trig, you are actually finding the angle measure. When you have your inverse trig, you're actually finding that angle measure because you're swapping that input and output. Instead of having the sine of theta, now I'm looking at what angle measurement goes with this value. And that's the question that you ask yourself. You ask, what angle measure goes with this value? That's what you're asking yourself anytime you have your inverse trig. For example, smiley face because we're going a little rogue here. If I have the sine of theta is equal to 1/2, my question is, what angle goes with that? So I am finding inverse trig here of this 1/2. So what angle measure is going to give me the value of 1/2? All right. And if I have this, there are two ways you're looking at this. You can either say what is the acute angle measure or all angle measures. Okay. And that's what you're trying to find. So if I have this, and I want to say, where is sine of 1/2? This is where my head tells me if I'm hitting this at 1/2, my y, because it's sine at 1/2, that's coming over here to, oh dang, at pi over 6, or back here at 5 pi over 6, right? So 5 pi over 6 comes all the way over here. Oh my goodness, I keep hitting that doggone thing. So then this is going to be the square root of 3 over 2 1/2 negative square roots of 3 over 2 1/2. If I just want acute angles, that's going to give me the pi over 6 or 30 degrees, depending on what your question is asking for, right? If I want all angles from 0 to 2 pi, then I also have to include pi over 6 and that 5 pi over 6, right? So that it just depends on what the question is asking. If you just want your acute angle, because my value here for sine, being the y, is both of those. So pay attention. All right? Okay. So that's if we have something on the sweet little unit circle. But what if we don't have something on the sweet little unit circle? Such as in example 9. What if I want to figure out the angle measurement here where sine of theta is equal to 0.9677091 0.705. Now, why in the world they gave you something crazy like that? I don't know. That's nutso. So you literally are plugging that into your calculator. So you're doing the inverse sine of this big, huge, oh my goodness, I messed it up. 96770911705. Okay. You're just looking, I'm going to show you on the calculator. For my calculator, it has the same on both of these. All right. A lot of times you have your sine function button, and then the second key will be your inverse. Most calculators do it that way. All right. This says angle in degrees in the book. I didn't write that down, but that makes a difference. I'm already in degree mode. If it said angle in radians, then you would just change it to radian mode. So I'm going to hit this twice. That's how my calculator does it. And then I'm going to type in this craziness. 0.96770911705. Wowza. And I get 75.4. All right. So this is now equal to 75.4 degrees. That's all you do. You literally plug that into your calculator. Tangent, cosine, all of that. You just plug that right in. All right. So if you have your calculator, then you can pull that off. What if it's actually a nice one? And for like example 10, I'm specifically asked to find the acute angle. All right. I'm going to put this degrees, just so that if we look back at it, you'll know what that's talking about. And here I'm going to find the acute angle that satisfies this given condition. So if I want to look where cosine of theta is equal to 1/2, then I'm asking that question. Where is cosine equal to 1/2? The acute angle. So what I do in my head is I say, where is my x-axis? Well, I know that's going to be this one up here. So does it tell me degrees? I missed that. Express your answer as an inverse trig in a measure of degrees. Okay, so up here in this measure of degrees, that would be 60 degrees, where I have this 1/2 and square root of 3/2. So in this instance, inverse cosine of 1/2 is equal to 60 degrees. See that? Okay. What if I want to find tangent theta is equal to 1? Again, with the acute. So then I'd chug it out. Now here's the thing. On my unit circle, tangent isn't on there. I'm looking at sine and cosine. So how do you figure tangent out? Where do I have the same values for both sine and cosine? Yeah, you do. Right up here at this 45 degrees, right? Because that's the 1 over square root of 2, 1 over square root of 2. Or square root of 2/2. I don't care, however you want to write it. But the point is, it's the same thing on the top and the bottom, right? So if I look at this and I say, I'm going to find inverse tangent of 1 is going to be the same thing on the top and the bottom, that's going to get me at my 45 degrees. All right. Using the relationships between sine and cosine, back and forth, working through all of that, that's how you get this stuff figured out. All right. Okay. So check this out. That's finding the acute. Remember, we said there's 2 different ways to go about this. For example 12, it says find all values of theta if theta is in the interval from 0 to 360 degrees. And cosine of theta is equal to negative square root of 2 over 2. All right? So, look, I want to point something else out right now. Notice there's a bracket on the 0 and a parenthesis on the 360. These happen at the same value, so you can't count them twice. You're either going to have one or the other, and we always use 0 is what's counted up to 360. Okay, there's just a side note for you. You're welcome. Now, let's figure out what in the world's going on here. Where is, if I have this negative right here, where is my cosine values negative? Because I really want to know the cosine of negative root 2 over 2 to get my theta. Yes, over here to the left, right? That's where I'm going to find cosine is negative. If I want to find all values between 0 and 360, if I'm coming over here to the left on this, where is cosine root 2 over 2? Negative tells me I'm in either quadrant 2 or 3, but where is root 2 over 2? Yes, this is that 45-degree mark. But at 360 degrees, in both of those spots, I have to figure out what is my angle measurement in order to get there. Because I always think in terms of pi with radians. So if this is 90 right here, right? This is my 90 plus that 45, 90 plus 45. This will give me 135 degrees. This is positive root 2 over 2. Down here, then, if I add an additional 90 degrees, because it's 45 to get there, or I'm going to look at 180. So 180 degrees plus 45, if I'm going all the way around to get there, what's that going to get me to? Yeah, 225. Okay, good. So this is going to be negative root 2 over 2 and negative. Do I care about what my y values are? Because I'm talking cosine here, people. So what angle measurement is going to get me this negative cosine? Theta is 135 degrees and 225 degrees. Because it's negative, oops, I meant to do my circle here. Because it's negative, I know that it has to be for cosine over here to the left. Right? All right, same concept. Now we talked about it, but I'm just going to put it in here because I always just think in these terms. What if this had said I'm going from 0 to 2 pi? Then what would you have? Yes, coming over here, I've got 3 pi over 4. And then all the way around, so this is one full 4 pi over 4, plus an additional one would give me that 5 pi over 4. Okay, good. Then you would have this exact same thing. So inverse cosine of the negative square root of 2 over 2 would then end up being 3 pi's over 4 and 5 pi's over 4. So it doesn't matter if you're talking degrees or radians, the process is exactly the same. All right. The big thing over here is I want to know where the x values are negative because that's my cosine. All right. Inverse trig. What